All right, so this video is going to be from questions 13 through 25. So question number 13 says, Henrietta graphed the equation f of x. Remember, that's the same as y equals 7x minus 2. Lewis then graphed an equation that was a line 3 units above Henrietta's line. Which equation could have been one of Lewis's graphs? So what you could do here, remember that f of x is the same as y equals, so you could graph Henrietta's graph, and that was 7x minus 2, 7, and make sure to use this, 7x minus, let me move this out of the way, 2, graph it, and it shows it way down here. I'm going to zoom in a little bit, so because my eyes can't see that very good. Oh goodness, that still doesn't help me. But I do know, here's what I know. I know that my y-intercept is at -2. So if he's 3 units above it, his y-intercept should be 3 bigger. So if I went -2 plus 3, his y-intercept should be 1. And I'm going to look at all of these lines. This is a y-intercept of -2. A y-intercept of 1, -5, and another -2. So if he's 3 units above, that means bigger. Henrietta's graph was a y-intercept of -2. So to get 3 units above, I went -2 plus 3, which was that +1. And that only option is B. Okay, number 14 is just a nice equation. I got to solve this. I'm going to make my equality bar. 7x minus 45 needs to equal 25 minus 3x. So I'm going to go ahead and get x to one side. I'm going to move my minus 3x by plussing 3x to both sides. And that's going to give me 10x once I get this done. So I get 10x minus 45 equals 25. It just takes me forever to write it. 10x minus 45 is equal to 25. And then I'm going to move what's not sticking to my variable. So I'm going to move my minus 45 by adding 45 to both sides. And I can't do that in my head, but with how long this takes me, I'm able to. What I do to try to do it mentally, I say 25 plus 5 is 30. Add another 40, that would be 70. So 70 is equal to 10x. And sticking together represents multiplication. So to get rid of multiplication, I go ahead and divide both sides by 10. Well, just 10, and x is 7. So my x is equal to 7. And you can check your work. Please know you have plenty of time. So just double check, and take the time to double check. So 7 times 7 minus 45, they should equal each other, both sides, is 4. Now I'm going to do this side. 25 minus 3 times 7, enter, is also 4. So I did find the right one. Okay, number 15 says no calculator. Be respectful of that. We need to simplify the following. So this is an exponential expression. 9 has the same base. So what we can do is the division property of exponents. And that tells us if we're dividing with the same base, we can just subtract the exponents. So it will be 9 to the 4 minus 6. So 9 to the 4 minus 6. And that's equal to 9 to the -2. My 9s, I can't even handle. And then you can't have negatives. You can't have a negative exponent, so you need to scoot that over to the bottom and make your 1 come out. So 1 slash 9 squared. And since it's a nice, easy power to deal with, we go ahead and evaluate it. So that'll be 81. So 1 slash 81. Okay, number 16. Oh, goodness. Which of the following lines below forms a system of equation that has an infinite number of solutions? Infinite means that everything will cancel out and it will be like 0 equals 0. It's a true statement. So there are a lot of equations and possibilities to connect it. So I'm just going to I'm going to guess and check what they asked me to first. So equation 1 and 2. 3x minus y equals 3.5. In equation 2 is 4x. Well, good gracious, I gotta type this up. Okay, so 4x minus 2y. I can already tell it's not going to cancel out, so I could stop here, but I just want to show you. I mean, you don't have to work all these all the way through. So what I want to do is cancel out. You could cancel out the y's by timesing through by a -2, because that would turn this to a positive 2y. Or you could times this by -4 and this by 3, or vice versa, this by 4 and this by -3. I'm going to go ahead and do my y, because then I only have to do one equation. So I'm going to times through by a -2. And then I'm going to plus a negative and make a 1 come out. -2 times 3 is a -6x. That's where I know I can stop, because -4 take away 6x doesn't cancel everything out. So I know that everything wouldn't cancel out. -2 times a -1 would be plus 2y. That would cancel out to -2y and plus 2y, but this wouldn't cancel out. So I'm going to go ahead and stop now. Okay, and then the next one, it says equations 1 and 3. So 3x minus y is equal to 3.5. Trying to write it nicely. And then equation number 3 is 12x. I think this one might be it. And I can tell by if it's a multiple. Minus 4y is equal to a positive 14. Okay, so I'm going to choose to do linear combination with this. So I'm going to turn this to a positive 4, because then I would have positive 4 and -4, and they would cancel out. You don't have to. You could go ahead and times this by -4, and then you'd have -12x and positive 12x. Actually, maybe I'll do that. But I just really worry about you remembering that this is plus a -1. So don't forget that, because it's very, very important. So I'm going to cancel out my x term. I'm going to times this first equation by -4. So -4 times 3 would be a -12x. Notice that they will cancel out. That's exactly what I want. I turn this to plus, so I'm going to write plus here. -4 times a -1 is a positive 4y. So these cancel out. I'm on a good step here. Cancel, cancel. Now I just want to make sure that this hopefully will turn to a -14, which I don't know. Now you got to distribute all the way over there. -4 times 3.5 is, I have no idea. -4 times 3.5 is a -14. There we go. So I can be done. -14. And then I have cancel, cancel, cancel. And I have nothing left on the left. I have nothing left on the right. And that means infinite. That really means they are the exact same lines. It means they intersect all the time. If I had a line going like this, the other line would be the same thing. It would just be a multiple. So they always intersect. All right, number 17. A bicycle rental store charges $12 to rent a bike for let me read that again. A bicycle rental store charges $12 to rent a bike and $4 per hour. So $12 is just to get the bike, and then it's $4 an hour. Which of the equations gives the total cost of renting the bike for H hours. So this says the cost is equal to 4 times each hour plus 12 bucks. This says the cost is equal to 4 bucks plus $12 each hour. This one says the cost is equal to $6 for each hour. This says the cost is equal to $4 for each hour. So $4 for each hour doesn't account for the 12 bucks it cost. And you don't have to pay $16 an hour for letter C here, because you just pay a one-time fee of 12 bucks, so that's not it. This says that it's $12 for each hour plus a one-time fee of 12 bucks or 4 bucks to get the bike, so that is also not it, which tells me this is it. Remember your rate of change, what changes your slope is whatever the per is. So $4 per hour should stick to the variable. And this is your initial amount, which is like your y-intercept. Okay, number 18. Which line is perpendicular to this? All right, these always take a little bit of work. It's annoying, but again, you got nothing but time. You don't care about anything but the slope. I'm going to go ahead and multitask like I showed you in class before. So I'm going to subtract 4x to get that to the other side, and I'm also going to subtract 5 to get that to the other side. So now I have 7y left on the left side equals, oh gosh, that's a y, negative 4x minus 5. And I don't need to care about the minus 5. I'm just going to write it there just to be proper, because all you care about is slope. Remember, perpendicular means you flip it, make it the opposite side. So now I'm going to divide through by 7. And now that's all I need to care about. So I have my slope. My slope is right here, negative 4/7. So now I can identify my perpendicular slope. So my perpendicular slope would be flip it, 7/4, and then make it the opposite side. So since it was negative, it will be positive. And now I got to find the match. So again, all you really have to care about is getting the x term over and dividing through by whatever is in front of y, because that's always how we handle this. But I'm going to add 7x, 7/4 x, and then I'm also going to multitask by subtracting 7 to both sides. Again, your goal is to get y alone. So then I have y equals 7/4x, and then what? Minus 7. And then if you look, I can be done here because my perpendicular slope should be 7/4, and the slope of this line is 7/4. So I'm going to go ahead and pick this just so I don't have to, well, actually I'm going to show you how to do this fast, just in case, to identify slope. So to identify slope, I would know that I would have to subtract 4x. So I get a negative 4x on the right-hand side. And then I would also have to divide by 7. So it would be negative 4/7 would be the slope. This one I would have to add 4x over. And then I would divide by what's in front of y, this 7. So my slope would be, I have to add 4x, so it would be 4x to the positive. And then I would divide by that 7, whatever's sticking to the y. In this one, I would move my x term by subtracting 7x. So then I would have negative 7x. And then I would just divide by what's in front of y, so divide it by 4. So my slope would be negative 7/4. Just kind of a faster way to do it than I normally do. Okay, number 19. The diagonal of a square measures 18 inches. What's the perimeter? So perimeter means that you add around. So I need to find the side length. So I like to draw a visual. If the diagonal of my square is the square root of 18, it looks like I made a triangle. So when I make a triangle, I can use Pythagorean's theorem. So I'm just going to go back to our formula sheet. Pythagorean's theorem says a squared plus b squared is the c squared. So since it's a square, it's the same side, so I'm going to go ahead and call it x, and I'm going to make a 1 come out. So 1x squared plus 1x squared is equal to the square root of 16. So 1x squared plus another 1 plus another 1x squared, and you didn't need to make the 1 come out, but I just did, is equal to the c squared, so the square root of 18 squared. And go ahead and punch that into your calculator for the square root of 18 squared. And that would be second square root 18, and then get out of the square root, square it. It just turns into 18. So now I can also combine like terms because they're both x squareds. So 1x squared and another x squared is 2 of them. So 2x squared is equal to, and we did this in the calculator, it turned to 18. Now I'm going to get my x squared alone, so I'm going to go ahead and divide by 2. That's an 8. Divide by 2, and you get x squared is equal to 9. And then take the square root. So x is 3. So that means each side length is 3. I'm going to escape this once. So since each side length is 3, again I want the perimeter, which means to add around. So it's going to be 3 and 3 and 3. Hey, I'm getting a little better with my 3s, and 3, and you add around, not that one. 3, 6, 9, 12. So my perimeter is 12. All right, number 20. Use the scatter plot below for questions 20 and 21. Okay, so I'm just going to analyze it quick. It says use golf clubs, age and years, and the price per tens of dollars. So it looks like as it's getting bigger, the value is decreasing, which makes sense. Okay, so the scatter plot shows the amount of money Eldrick received selling 16 used golf clubs. He drew a line of best fit, that's this, to determine how much he should expect to receive when he sells a golf club, which is the best estimate of how much he should receive if he sells a 3-year-old golf club. So I'm going to go to the 3 years old and just follow this line up. It's right around here. So, and this is in tens of dollars, so between 80 and 90, I'm just going to find the best match. Between $7 and $10, no. At least 100 would mean he got more than 100, no. Less than $70, no, because I got between 80 and 90, so no. Between 75 and 95, that's the best match. Okay, 21. Which of the following best describes Eldrick's finding? The value of a golf club increases approximately $10 each year. That definitely can't be it because it keeps decreasing. The value of a golf club decreases by $1 a year. Maybe, I don't know. I have to look at, this tells me I need to look at slope. The value of a golf club decreases by $10 a year, maybe. The value of a golf club decreases by 13 a year. So it's one of these. So what I need to do is find the slope. So what I'm going to do, I need to zoom in because my eyes can't see this. I'm going to find some perfect points, and then I'm going to find the slope of it. So here's a perfect point right there, and another perfect point I'm going to say is approximately right here. I don't know. I think so. Pretty close. So it looks like I went down. This is by tens of dollars. So down 10, 20, 30, 40, $50. So down 50. And then I have to look to see how my years are increasing. And it looks like by 1. So over 1, 2, 3, 4. So down 50 over 4. And I'm just going to see what that is. So negative 50 over slash 4 is negative 12.5. So what's my best match here? 12.5 D is my best match because 12.5 is closest to 13. Okay, which of the following products is irrational? So irrational means it's not a perfect square root or it's pi. So this is a perfect square root because you could even punch that in. As long as you don't get a decimal, all is good, except for this one. Repeating decimals always go over 99. You can turn it to a fraction. So this is definitely rational. Okay, because I have rational times rational, which would turn rational. So I'm going to just go 9 times the square root of 16, which is 4. It's going to be 36. So that's rational. So that's not it. The square root of 25 times the square root of 5. So I don't think the square root of 5 is rational. Ooh, what's that? So second square root. Oh, I messed up again. So second square root 25. Get out of the square root times square root 5, enter, and I get a decimal, which tells me it's not repeating, so it's irrational. And that's because the square root of 5 is irrational. If you punch that in, it's not perfect. And if it's not a perfect square, it's irrational. So this one is definitely it, but just let's double check. The square root of 25 times 16, so square root 25 times 16, enter, and that's a perfect number, so that's good. And this one, you just know, and we taught you this in 7th grade, that any repeating decimal is rational because it's really 7 in 45 99ths. That's what that decimal represents as a fraction, so you can turn it to a fraction. So the square root of 5 is my only irrational number. Oop, triangle. Anytime you see a triangle, you can use the lovely Pythagorean. So it says a 30-foot ladder, that's right here, is leaning against a building. The base of the ladder, which means bottom, is 10 feet from the building. About how far up from the building is the ladder? So my right angle is right here. That tells me this is the A and B, and 30 is the C. So you could just go x squared plus 10 squared equals 30 squared. Oh gosh, this is so hard to write with my trackpad. 30, I wish I could write pretty, squared. So now what we have to do is get x squared alone. So I'm going to go ahead and take away 10 squared from both sides. So take away 10 squared. And I'm just going to type that right into my calculator because calculator will do order of ops. So the calculator is going to square them both and then subtract them. So 30 squared, take away, was it 10? Yeah, 10 squared, which is 100. I could have literally just put that in, but whatever. 800. So now I have x squared left. So x squared is equal to 800. And then to get rid of the square, I'm going to square root. So I'm just going to take the square root of 800. So now I'm going to go second square root 800. And that is 28.3-ish. And I do see about a 28 right there. So that has to be the right answer. Okay. 24, which is the graph of y is equal to negative 2x plus 4. So this is in slope-intercept because y is alone, and that's the slope. Down 2 over 1, down 2 over 1, down 2 over 1. And the plus 4 is where it crossed the y-intercept. So my y-intercept would be right here, and then down 2 over 1. So that one's definitely not it. My y-intercept is right here, down 2 over 1. That one's not it. My y-intercept, it was 4, right? Yep, is 4. And I would go down 1, 2 over 1. That's not it. My y-intercept is 4. down 2, 1, 2, over 1, down 2, 1, 2, over 1, and that is the correct one. Again, another strategy that you could use, this would be a calculator option. You could graph it in your calculator, clear this, and then what was it? Negative 2x plus 4. So remember to use this button right here for the negative 2. Use this for the x, because if you use a Chromebook, you get that weird arrow. So please don't do that. Negative 2x, and then I get plus 4. Plus 4. You could graph it, and then you could find the match. So if I look at my graph here, I'm going to make my calculator over here so I can compare. The first one, it crossed the y-intercept down there, so that wasn't a match. This crossed way down here, so that's not a match. This crossed at the origin or the center, that's not the match, which tells me this is the only one that's a match. Okay, number 25, last one. Let y equal 8x minus 5. Suppose the value of x changes by 2. How much does the value of y change? So I'm going to make an input-output table for this one. And I'm going to go ahead and make my x start at 1 and figure out what my y is. So if x is 1, it's going to be 8 times 1 is 8, minus 5 is 3. And then I should be changing by 2. So my next one would be 3. And then I would have 8 times 3, 24. Take away 5 would be 19. And I'm just going to check one more, change it by 3. I should be 6. Okay, 8 times 6, 48. Take away 5 is what, 43? And then I'm just going to see how my y changed. So I'm going to make this over here now so I can look at my writing. 19 take away, I always do big minus small. 19 take away 3 is 16. Now I'm going to do this one. 43 take away 19 is 24. That doesn't make any sense. Oh, because I messed up. Silly me. This should be 5. I'm going to redo this. Because I was supposed to change by 2 and I changed by 3. Oopsies. Okay, so if it's 5, it would be 8 times 5 is 40. Take away 5 is 35. Now I'm going to check. So I know that 19 minus 3 is 16. Now I'm going to go 35 minus 19. 35 minus 19 is the 16. So that's exactly what I wanted. Notice that my strategy there, 8th graders, I made a mistake, and I knew it was a mistake because it should have been a constant rate of change. So I had 16 here. Whoops, move this out of the way. So I had 16 here and then 24. That's not constant. I knew it should have been 16, so I just double-checked my math, which I did wrong. Okay. All right, let me escape that and escape this, so I know that the y changed by 16. Okay, part B. Suppose the value of y changes by 40. How much will x change? So again, I'm going to make an x and y table. And I'm going to make my y equaling 1, or you could do 0. Should I just do 0? It's easier. 0. Okay, and then you have to do some algebra. So if y is 0, then you get 0 equals 8x minus 5. That's an 8x minus 5. So I'm going to add 5 to both sides. If I add 5 to both sides, I get 5 equals 8x. And then I'm going to divide by 8, and I get x is equal to 5/8. So 5/8. Now I'm going to add 40, because that's what I want my y value to change by. Okay, so if I get 40, that's what y should be. Notice that I'm looking at my y, which is by itself. So 40 equals 8x, then what, minus 5. And then I got to do some algebra, so I'm going to add 5 to both sides. And I get 45 equals 8x, and then divide by 8. So 45 is equal to, when it's 40, and I'll show you how to type this into your calculator in a minute. I'm going to go one more just to make sure I didn't make a mistake like I did last time. Go up to 80. I really don't have much room to do this. I'm going to do it right here. So 80 is equal, I'm trying so hard to write nice, is equal to 8x minus 5. And so I'm going to add 5 to both sides, and I'm going to get 85 is equal to 8x. 85 is equal to 8x, and then divide by 8. So 85 So 80, oh good gracious, 85 Okay, so now I'm just going to check to make sure that they should also be a constant rate of change. So I do big minus small. I'm going to go 45 take away 5 which I know is 40 but I'm just going to show you how to type it in. I always do parenthesis anytime I deal with a fraction. So parenthesis 45 slash 8 parenthesis take away 5 so I'm going to do parenthesis 5 slash 8 parenthesis enter, and that was a 5. And now I want to make sure that this is constant, that 85 minus 45 is constant. So parenthesis 85 slash 8 parenthesis take away parenthesis 45 slash 8 parenthesis, and that is also a 5. So my y value changed by 5. Notice, 8th graders, that my strategy here was an input-output table, my x and y table. So what I did is just picked a value. You could do, since x changed by 2, you could go 0 to 4, and you change it yourself. Figure out your y and compare. When I had my y value change by 40, I went 0, 40, 80, and then I had to do algebra because your equation is right here. So I had to do algebra to figure out what my x is and see what that constant rate of change was. So that is the end of review day, what are we on? 3. Review day 3 is all done. If I can close this out, but I don't know if I can. Okay, bear with me as I try to close this out. I think I did it. I'm going to go